Hello, everyone, and welcome back to Simcyp Technical Webinar. My name is Xian Pan. I'm part of the Translational DMPK group at Simcyp Certara. I will be your host today. So today's topic focuses on the Simcyp-R package. Before we start talk, I'd like to kindly request that everyone stay muted during the presentation. Should you have any questions, feel free to raise your hand or post your queries in the chat box. We have dedicated Q&A session at the end where we will address all your questions. Next slide, please. Thank you. It's my pleasure to introduce today's speaker, my colleague, Antonia Anasava. Antonia is a research scientist at Mechanistic Modeling Group at Simcyp Certara. She has involved in the development of the Simcyp-R package, Simcyp parameter estimation tool, and the sensitivity analysis tools. I'm glad to have her with us today to introduce Simcyp-R package. Her talk will cover the brief introduction of R package, Simcyp-R package, the new features in the version 23 package, and also where to get help when you're using the Simcyp-R package. Without further ado, I will hand over to Antonia. Antonia, the floor is yours.
Thank you very much, Jan. Okay, so let's get started and let's talk about the Simcyp-R package. So you're all familiar with the Simcyp screen, in other words, the graphical user interface, also known as the GUI. So what we did in version 24 is that we separated out the GUI from the Simcyp engine. So for this reason, we are now able to communicate to the Simcyp engine via other platforms such as MATLAB and R. So now that the engine is separated out, we created the Simcyp-R package so that we can communicate to the Simcyp engine from R. Okay, to run a Simcyp simulation from R, what do you need? The first thing is that you will need to have the Simcyp Simulator version 23 on your local machine. The Simcyp-R package can connect to both the human simulator as well as the animal simulator engine. You would also need to have R installed on your local machine. The version that you will need is version 4.3.2. And finally, you need to have the Simcyp-R package on your machine. The latest package is version 23.0.64, and this package is able to connect to Simcyp engines from version 21 to 23. So, for example, if you have Simcyp Simulator version 21 on your local machine, you can use this package to connect to the version 21 Simcyp engine. The same goes for the version 22 simulator engine. Okay, so how can you run a Simcyp simulation from R? The general workflow is that the first thing you will need to do is to create a workspace. So as normal, you open up Simcyp and you'll be in the screens, and all you need to do is just pretty much save a workspace to your local machine. Once you've created the workspace, the next thing that you need to do is to load the Simcyp package into R. So once you've requested for this package and you have it on your machine, you load this package and now you're able to use the package in R. To do this, you can use the function called library and then just call the package name, which is called Simcyp. The next thing that you need to do is to initialize the package. To do this, we use the function called initialize. And what this will do for you is it would initialize to the latest Simcyp version. And you will need to specify the species ID in this function. To do this, you need to say, okay, species ID is $human. If you wanted to connect to, let's say, the animal simulator engine, you need to mention, for example, the species ID is $rat or monkey. To initialize to previous Simcyp engines, you would have an additional step within this function, which is specifying the file path of the version 21 simulator engine path. There are examples within the package that you can have a look at to do this for you. Once you've initialized the package, the next step is that you will need to import a workspace. This workspace can be a workspace that you need or a default Simcyp workspace, but as long as a workspace is imported into R, this means that you can connect to the Simcyp engine using the Simcyp-R package. Once you've imported a workspace, so in this example, we're using a function called setWorkspace to do this. And within that function, you specify the workspace name with the extension WKSZ. So what this will do for you is it will spit out a summary of that workspace that you've imported. So this is a good indicator to just check that you're importing the right workspace. So for example, you will see that it would give you a summary of the workspace, for example, the substrate name, the absorption model that is used within the workspace, the distribution model, elimination model, and so on and so forth. You would also see the population type that is being used. So in this case, is a healthy volunteer, and you will see a summary of the trial design. So for example, the maximum and the minimum age and the proportion of females. So you look at having this information is useful just to make sure that you're importing the right workspace. Once you've done all these 4 steps, so created a workspace, you've loaded the package, and you've initialized the package, and you've set a workspace, now you're able to run a Simcyp simulation from R. To do this, we use the function called simulate. And within this function, you need to specify the database file name. So what will happen is once you run this function, automatically in your local directory or your working folder, you would see a database file being created. This database file will consist of the simulated results of that particular workspace that you've loaded in. What we have in step 4 is when you import a workspace, there's also an additional steps where you can also choose to modify that workspace. I will explain this later on in the presentation. So this slide is just showing you what are the major steps that you need in order to run a simple and a basic Simcyp-R script. Now, on screen, you can see the list of functions available within the Simcyp-R package. The functions highlighted in blue are what I'm going to call the setup functions. So in the previous slide, we talked about the things that you need in order to run a Simcyp-R simulation. So like I said, you need to initialize the workspace, you need to set the workspace, and now you're able to run a simulation using the simulate function. The next group of functions are what I'm going to call the getters. So what you will notice about these functions is that they all have the characteristics get before the function names. And what these functions do is that within that workspace that you bring into the Simcyp-R script, it goes into that workspace and gives you the parameter value. So assuming you've forgotten what the molecular weight value is within that workspace, you can use the function getCompound parameter function to go into that workspace that you're bringing in to remind you of the parameter value that is used for the molecular weight. Let's now say you now want to change the molecular weight value. You want to modify the workspace. This is the reason why we have the functions called setters. So what these functions, they all have set before the function names to keep things easy and memorable. So these functions will go into that workspace and they will change parameter values for you. So you're able to change compound parameters or population parameters or PD parameters, whatever that you can see on screen, you can change those parameters from R without having to, go into the workspace itself and change it manually yourself. The next group of functions are the output DB functions. What you will notice about these functions is that they all have DB at the end of the function names. So once you've run a simulation, that's when you're able to use these functions, because what these functions do is that they go into that database file that is being created by the simulate function, and they extract the simulation results for you. So assuming you were interested in knowing what the simulated age is for the population, you can use get all individual value DB function to extract this the simulated age. The same goes for, let's say, the AUC, the simulated AUC. You use the function called get AUC from DB function to extract the AUC results. The same goes for the profiles. You use the function called get profiles DB function to extract the profiles, the simulated profiles. Finally, the next group of functions that we've introduced this year is the plotting functions. So what these functions do, they all have plots before the function names to make them easy to identify. And what they do is that they create plots for you. So we have the plot forest DDI, which will create a forest graph for you. We also have a plot profile CI, standing for confidence interval DB function. And then finally, we have plot profile percentiles function. So now I'm going to talk about how to extract and change Simcyp parameter tags. So as I mentioned before with an example with the molecular weight, in this example, we can see that we're interested in the FA value. So for compound parameters, so this is any parameter that you see in the substrate tab, for example. We use the function called get compound parameter. Within this function, you will need to specify the tag ID and also the compound. An example is what we can see down here. The first part, like I said, is the tag ID. To know what the tag ID is for the parameter, the best way to do this is go into the Simcyp graphical user interface. Once you go into the Simcyp graphical interface, you will need to navigate to your parameter of interest, and then you right-click on this parameter. So as you can see in this example, a right-click on the FA input box shows you this pop-up window. At the top of this pop-up window is the tag ID for this particular parameter. Clicking on this tag ID will copy the text for you to clipboard, and then you can now come back into R and paste this within the function. You only have to do this one time. So once you have your tag ID and you're happy, you never have to go back to the Simcyp workspace. You just want to do this step to identify the tag for FA, for example. Once you've mentioned the tag ID, you then also need to specify the compound ID. This part is important because we have different compounds within the Simcyp simulator. So in this example, I'm showing you where we are interested in the FA value for the substrate. Assuming you were interested in knowing what the FA value in inhibitor 1 screen is, you will need to say that the compound ID is $inhibitor 1 or inhibitor 2 and so on and so forth. Once you're happy and you've gotten the value for FA, but you wish to change this value, for example, to 0.5. To change the values of parameters, we use the function called set compound parameter. For this particular function, you also need to mention the tag ID. The tag ID is the same thing. The compound, so which compound you're interested in, substrate or inhibitor. And then finally, you mention the value that you wish to change this to. So this is the steps that is needed. So the first thing is you need to open a Simcyp workspace, extract the tag ID, and then mention the compound. And if you want to change the value, and specify the value. For population parameters, the same step is also necessary, but the only difference is that the function name is different. Here, the function to change population parameters, so any parameters that you see in the population screen, so for example, in the demographic screen, you would need to use the function get population parameter. For this function, you also need to specify the tag ID as well as the population ID. To set these values, the difference is you just change get to set, and then this will change the parameter value for you. The same goes for the PD parameters, but the function name is different. Where we call the function name get PD parameter. And then finally, the same goes for the simulation toolbox parameter. The function name for this is get simulation toolbox parameter. So we've done our best to kind of make sure that the function names reflect what you see in the Simcyp screen. Yeah. So moving on how can you run a Simcyp simulation and save the results to a database file. The first thing that you need to do is just to make sure that you're working in the right working directory. To do this, you can use the function called script location. What this would do is it would go to find the script location for you, and then you can now set the working directory to this script location. Once you've done that, this example is just showing me mentioning the database file name that I wish to create. So in this example, I'm going to create a database file that I'm going to call demo_basic.db. And then finally, I'm just creating an object where I'm going to store the database file path. To run a simulation, you need to use the function called simulate. And then within that simulate function, you mention the database file. In this example, I'm just mentioning the database file path. So I'm mentioning the full path rather than just the name. And this consists of the path as well as the demo_basic.db file name. So once I've run a simulation, automatically in your working folder, which is this path, you would see a database file being created, and that database file will be called demo_basic.db. Once that file is created, I can now go into that database file that is created and make a connection to that file. And then once that connection is done, then I am now able to go ahead and extract the simulation results. So how can you access simulation results from Simcyp-R? One of the functions for individual parameters, one of the functions that's available is get individual value DB function. For this, you're able to extract, for example, every parameter that you see within Simcyp Excel, the demographic sheet. So for example, the age, the weight, the height of the subject. We use this function to extract the values for each subject. So in this example, the first item is telling me, okay, I want the age value for subject 5, and I'm also mentioning the RSQLite connection. So once I've run this function, it would report the age value for subject 5 for me. The second line here is doing the exact same thing. The difference between the two lines is, in this case, I'm writing the tag ID as a string, whereas above, instead of writing the tag ID as a string, I'm using the $ method instead. As you can see, it's going to give me the same value. To extract the population value rather than doing it one at a time for each subject, we've created a function called get all individual values DB. And for this function, you don't have to mention the individual number. You just need to mention the individual value ID, which is 8 in this example, and then the RSQLite connection. Once you've run this function, you will see it would report the age value for the full population for you. So if I let's say count, for example, subject 5, and I go 1, 2, 3, 4, 5, you will see that for subject 5 the value is the same thing. Below is an example for compound results. So assuming I'm interested in extracting the adjusted FU that was simulated, I use the function called get compound results DB. For this, you mention the individual number, the tag ID for the results parameter that you're interested in, the compound in this case, so substrate. If it was an inhibitor, you would say compound ID is $inhibitor1, and then also the RSQLite connection. Once you've done that and you run the function, it will give you the result for subject 1. To extract the result for the full population, you do the same thing, well, using a different function name, where the function name is get all compound results _DB. For this function, you don't need to specify the individual number. You just need to specify the results ID that you're interested in, as well as the compound and the RSQLite connection. Moving on to profiles, so extracting profiles. To extract profiles, we use a function called getProfilesDB. And what this function requires is that you will need to specify the tag ID for the profile. In this example, I'm showing you one for the time profile and then one for the systemic concentration. Focusing on the time profile, the tag ID for the time profiles are n times sub. The compound just for the time profile is -1. And then you will need to specify the individual number, the RSQLite connection. Just for the time profile, the inhibition is always set to false. In the case of the systemic concentration profile, we're using the same function. However, the profile ID in this case is CSIS. And then the compound ID is we're interested in the substrate systemic concentration profile. Same for subject 5, the RSQLite connection for the database file. And then in this case, depending on whether your simulation was a DDI simulation, you would either say inhibition is equal to true if the DDI is present, or you would say inhibition is equal to false if DDI wasn't present. So once you've run these two functions, you can now create a basic plot or ggplot. In this example below is just the time against the CCS concentration profile for subject 5. Assuming you wanted to see this for the full population, you will need to write this code in a for loop, where the for loop will start off with subject 1, generate the time and the systemic concentration profile for subject 1, then store the data, move ahead to subject 2, generate the time and the systemic concentration for subject 2, store the data, and so on and so forth up until your final subject number. And then once you've stored the data for the full population, then you're able to create the concentration time profile for the full population. Assuming you wanted to extract the PD profile, for example, all you need to do in this example is change the profile ID is $PD response. So that's the tag for PD. Okay, so what's new in version 23? So we introduced population summary, trial and population summary statistics. So one of the function is get individual value stats DB. So what this would do is for demographic data such as the age, body weight, and so on and so forth, you're able to see the summary statistics either for the trials or for the population. So in this example, the tag that we're interested in is the age, simulated age. And here I'm mentioning the alpha value that will be used to calculate the confidence interval, as well as the upper and the lower percentiles. And then finally, I will need to mention that the trial is equal to true or false. If you say the trial is equal to true, this will give you the trial statistics. Whereas if you say the trial is equal to false, this will give you the population statistics. And then finally, you need to mention the RSQLite connection. When a trial is equal to true, the output that you will see is a table which looks like this, where you can see the trial number, the mean, median, geometric mean, GOCV, lower and upper confidence interval, lower and upper percentile, CV min, max, fold, and standard deviation for each trial. And this result is, for example, for the simulated age. To view this for other parameters such as body weight, you would also see this table for the body weight. If you set the trial is equal to false, it will give you a simpler table, but this is the population summary statistics rather than trial statistics. The same goes for compound parameters. So for example, if you wanted to see the summary statistics for adjusted FU, use the function called get compound results stats DB. And once you run this function, if the trial is equal to true, you will see the results looking like this table, or if the trial is equal to false, you would get the population summary statistics. We also have the population and trial summary statistics for profiles. So for this, we use a function called get profile stats DB function. Within this function, you mention the profile ID, for example, systemic concentration profile, the compound ID. Inhibition is either equal to true or false if you're interested in the DDI. You also mentioned the upper and the lower percentile value. And finally, whether you want to see the trial statistics or the population statistics. And you need to also mention the RSQLite connection. If trial statistics is equal to true, what you will see is the trial statistics for each trial. So in this case, you would get the mean, lower, and upper percentile for each trial. If trial is equal to false, you get the mean, lower, and upper percentile for the full population. Also, another new feature that we implemented in version 23 is plotting functions. So the first one that we can see on the screen is a forest plot. You can generate a forest plot by using a function called plot forest DDI. For this, what this would do is that it would give you a forest plot of both the AUC and the Cmax ratio, of the AUC and Cmax ratio. In order to have generate the statistics for the AUC and Cmax ratio, for example, you would need to use the function called getForestData_db. And what this would do for you is it would generate a table from your database file consisting of the summary statistics of AUC and Cmax ratio. Once you have that table, you bring that table into this function, the plotting function, the plot forest DDI function. So this is where you mention the PK ratio data. And then within this function, you need to specify which mean type you're interested in viewing. So for example, the geometric mean or the arithmetic mean or the median. And then you'd also need to specify the variability type. So in this example, we're saying the variability that we wish to see is the confidence interval. But you can also choose to view the range, so the minimum and the maximum, or the percentiles, for example. You can choose to change the colors. So in this example, I'm just saying that the colors should be the yellow to red setting. And then finally, you can add legends to this figure. Once you've run this function, you will see an output which looks like this, a graphical output, which looks like this. Another plotting function that we introduced is the plot forest CI, confidence interval db function. So what this does is it produces a ribbon plot consisting of the geometric mean with the confidence interval. For this function, you need to specify the profile ID. So in this example, systemic concentration profile. And then you need to specify the compound ID, which is substrate in this case. Inhibition is if you have DDI if you've run a DDI simulation, you can either say inhibition is equal to true or false. If you say it's equal to true, you will see the simulated profile with and without DDI interaction. And you also, within this function, you need to specify the alpha value. In this case, we're saying alpha is equal to 0.05. This is used to calculate the confidence interval bands. And then finally, you need to mention the RSQLite connection. You can choose to color your graphical outputs. In this case, I'm just using the value 1 and 2, which represents the red and the black color. Or you can type this in using the red and the black characteristics. The final function that we introduce is the plot profile percentile. And for this function, you would get the mean profile along with the lower and the upper percentiles. So for this function, you specify the profile ID, the lower and upper percentiles, and you can choose to view this function with and without the ribbon plots. So where can you find help? The first place to go is within the Simcyp-R package is the help pages. Assuming you don't know how to run a function, simply navigate to the help page and go into that particular function, and it gives you the description of the function and example scripts of how to run each function. You also have the Simcyp vignette, where there are different example scripts, so a parameter estimation script, a plotting script, sensitivity analysis script that's already pre-written within the package that you can run manually yourself. To download the package to your local directory, all you need to do is send a request to simcyp.support@certara.com, and they would add this package to your members area. You will see this package in your members area. And then finally, there are various e-learning videos that we are adding to the members area, which you can go and view. These e-learning videos also consist of files that you can request to run yourself. Here is just posters that has been presented in the past. And finally, here is a publication that was also written by our colleague Hiba in 2022 that you can also go and read. There is a YouTube video that you can watch as well regarding this paper. And this, yeah, that is it on my presentation. Are there any questions?
Thank you, Antonio. We have one question from the chat box for you.
Okay.
Okay, is there a list of parameter ID tags so we don't need to go back and forth between Simcyp and R? And another one is, do we have the option to output the results to an Excel file?
So with the latter question, which is output the results to an Excel file, Unfortunately, you can't do that with the Simcyp-R package. However, you can use the output tool to view your database file as an Excel a file. So what I mean is, once you run a simulation and automatically a database file is stored in your working directory, you will need to open the Simcyp output tool. Once you open that Simcyp output tool, you can bring in that same database file into the output tool and view the results in Excel. So that's one way of doing that. For the first question, in terms of knowing all the viewing all the parameters in one place, there are thousands of parameters. So we are working this year to have, I guess, a screen interface that would have all the parameter lists. But the best way so far right now is to go into the Simcyp screen and extract the parameter tags that way. But if you wish to view the parameter tags, there is a function called find enum function that you can use to view all the parameter tags. But like I said, there is thousands of them, so it may be difficult for you to scan through all of them to look for your specific parameter. The easiest way is to just go through the Simcyp screen.
There are another question asking about, can we perform the parameter estimation in Simcyp-R package?
Yes, you can, as long as you know how to write the script. That is possible to do. Like I said in the example, in the where to find help slide, there is a parameter estimation script that you can open and run yourself, which is giving an example of how to run parameter estimation using the Simcyp-R package. And what this does is it uses Optim to optimize your PE.
Okay, so that's all the questions we have. And we will now bring this webinar to a close. Thank you to Antonio for guiding us on the Simcyp-R package, and thank you all for joining us. Should you have any additional queries later on, please don't hesitate to get in touch with us. So our next technical webinar is scheduled for the 20th of June. So in this upcoming session, I will talk about how to simulate the cytokine-related therapeutic protein DDI using Simcyp TP modulator module. So this is another new feature in version 23. And if you're interested in it, please register through the members area. Once again, thank you for being with us today. We look forward to seeing you soon. Have a lovely day and goodbye.